And we should be good.
All right. Well, I've got 3:30 then, so I'm going to go ahead and get started. Thanks, everyone, for coming out to this talk. My name is Adam Hogan. It says on the screen there. I'm a security engineer for Cisco by way of the SourceFire acquisition, where I was for 5 years. This is not my whiteboard. My whiteboard, so no need to worry. I'll not be talking about weight loss or the importance of exercise. That's still very not my topic.
Yeah, can you speak up a little bit more?
All right. Is that better? Okay. So I'll stay a little closer now. All right. So what I'm talking today is some of the newer features in Snort, some of the underutilized features in Snort, sort of take it beyond what IDS has typically done, and start doing some application control and some file control as well. All right, so that's primarily what we're focused on. The base news being that there's a huge new feature called Open App ID, which was recently open sourced and now available with the most recent Snort release, 297, which again you can download from snort.org, where we're doing all the application identification in Snort and all completely open source. So when you start to talk about your Next Gen Firewall, your Layer 7 firewall, being able to identify not just the threats going on, but telling you what application it is. What type of web browser was that? Was it talking to Facebook? Was it on Facebook chat? Was someone trying to use Skype? And you can now do all that with the open source version of Snort. Right? And as a disclaimer, I'm coming over from SourceFire. I sell appliances and things that use Snort. Right? This talk, however, is in no way a sales pitch. I don't think it has any place in a BSides, right? This is all 100% dealing with the open source software. None of this is about something for sale. This is all stuff you can do with open source software. You can literally download this today and do what I'm going to show you here. Okay. All right, so we'll talk about utilizing Open App ID, what you can do with it, and then some of the data we're going to get out of it. So I think it's worth starting with the definition, right? Because honestly, there's a lot going on here. If you were to ask any 5 NGF firewall vendors to define an NGF firewall, they would have at least 5 different definitions, most of which would probably single out theirs, right? So there's a buzzword that we have to watch because there's just too much of it going on, right? So I'll take Gartner's, which is basically, okay, it's a deep packet inspection firewalls move beyond port and protocol inspection and blocking to add application level inspection, intrusion prevention, and bringing intelligence from outside the firewall, right? So it's a firewall, it's an IPS, it's application layer firewall, right? That's everything we've got bundled into a Next Gen firewall, according to that definition, right? And that's what I'm going to be operating off of. So we can do that level of application control, right? We can say, okay, it's not just a matter of letting through port 80, because what the hell isn't port 80 these days, right? We want to look a little bit deeper into that and say, okay, well, what applications are they? What clients are being used? What application protocols are they using? What web applications are they using? Because we want to be able to control that now, right? Because it's not enough just to control TCP ports, because again, everything's 8443, right? So what we've done is released Open App ID. So these are our ability to detect and control at the application level. And this is, again, completely open source. So the engine itself is open source as well as most of the detectors. So we do now a, let's say bi-weekly, it's not that regular, but release of the application detectors. So for one, you can see how our engine works. The source is available. You can also see how our detectors work. If you want to know why or how we pick up a certain application, the code is right there. Right? You can download each and every one of our application detectors. Not everyone, actually. I think some of them are proprietary with input from developers. And so there's a few that are locked up. But the vast majority of all the application detectors we have are completely open source. So you can literally download scripts that identify each of these applications. So again, we don't want a black box, right? If we have a black box security operation that says, hey, there's an alert, why is there an alert? Just trust me, right? There's just flashing lights and it doesn't give me any information. Pretty limited use there, right? But no, we want to open source the complete process, right? So if you've got Snort up and running with some pretty minor tweaks, you can be doing application level firewall as well. All right, so the way this operates is actually as a preprocessor to the snort engine. If you've ever dived into snort before, there's a lot of different preprocessors in the snort engine, right? Because to do IDS well, you have to be able to normalize and reassemble the traffic you're looking at, right? It's not like you can grab one packet and then do a bunch of search and, just to see if it looks like an attack, right? If you do that, then we fragment our attack over multiple packets and no IDS ever works, right? Which is a problem in like the mid-90s, right? Before IDS has got worthwhile. So an IDS has to be able to reassemble, and has to be able to rebuild, it has to be able to normalize traffic. So part of the process is being able to rebuild IP fragments, to be able to put together a TCP stream, to be able to normalize the application layer data. And these are all things that snort does, right? So if you are looking for web attacks, we have to grab those IP fragments, we put them together. That goes through TCP stream reassembly, define that entire process. Once that's rebuilt, we can put it through HTTP normalization. Or because, I mean, for any given web request, there's like a million ways to write it, right? I could write the word, I could encode it, use its Unicode values instead, right? With 100 different ways to write a web request, we have to normalize. So that process has to happen. But now what we're doing is adding an additional preprocessor. Say, okay, well, if we've already rebuilt all these things, now let's send it, before it goes to the rules engine to see if there's an attack going on, let's send it through the application detection preprocessor. Then it goes through there, so we're able to see, after all the other preprocessors have worked to rebuild the system, now we can look at the application layer information and do our match to the application detector we have. To do this, there are a few more requirements, right? So if you've already rebuilt Snort, if you've already used it in the past, there's just a couple more steps we're adding to the process in order to do this. And the first is to install Lua, right? So Lua is a scripting language, and you need its development libraries or the just-in-time libraries installed on the machine before you can compile Snort now if you're going to do application detection. And that's because all of the application detectors are just simple Lua scripts. So there's this added step here to compile Snort in the first place, but it also means it's much easier for us to write an application detector. It also means it's going to be a lot easier for you to write your own application detectors, which of course you can do now that it's open source, right? So you can take a look at these scripts, see how it works, and write your own application detectors, which is something we'll walk through here in a bit. You also need to compile, like right when you do your configure option, you need to compile, enable open app ID. So if you're already working with the latest Snort but didn't compile to do application control, you have to recompile. Right. So not a big step, just one other thing to take in the process when you download the newest source and compile it. You'll also need the application detector package. Again, I mentioned we were open sourcing all the detectors themselves. What we have is a bundle of all those Lua scripts for all the applications we have open source, a couple thousand right now. You can download each of those. Those do get updated periodically, so you can grab those as well. So you'll need those downloaded and with your Snort installed to be able to use all those. Right? But again, all that's for download on snort.org. Preprocessor we talked about. What we do need to do is add a couple of lines to the snort.conf. And sorry this looks confusing. What I'm doing is it's sort of assuming you know a little bit about how Snort's configured. If you have worked with it before and all this looks like Greek, don't worry about it because these steps are fairly short just to get things up and running. And we've got all this documented on snort.org. Right, there's some fairly extensive documentation up there. There's a couple of blog posts on the Snort blog I have up there about getting all this running, and you can check those out as well. So I'm not going to spend time going through and how to compile and doing that from start to finish because that's fairly well documented. I'm going to focus instead on what's new and how can we use it. Right? But if you have any questions about that, check the documentation out or just send me an email. Right? But we do add this have to add this line here by default. I mean, when you download Snort, there's a snort.conf file in there. How you're going to set up, how you're going to run Snort, what rules you're going to run, and all those things to tweak the Snort engine. Right? It doesn't include application control by default, right? So that's something you have to add. So we actually add that preprocessor statement and say, okay, I want to do app ID. And all we really have to do is specify a log file here. So the app stats file name, you're just saying, okay, here's the file name I want to save it to. So we actually have a new log file we're going to be producing now. We're running open app ID. That's going to be collecting statistics of what applications are on my network So we'll be able to dig through what apps are out there, how much traffic they're utilizing. We'll have all that data to dig through as well. So we're giving it the file name there, and then we're just telling it how often are we going to write that data out. That's the app stats period, right? Because we're not going to write that data live or periodically do that. And then we give it the directory of where we downloaded all the application detectors, right? Again, I mentioned that's one of the other things you have to download is that bundle of all the application detector Lua scripts. You're going to put those in the system, and then you just have to tell it what directory all those are in, right? So once you've got that set up, you're going to restart Snort, and it's going to be running our application detector. So I mentioned needing that application detector package. So let's take a look at what's in there. First of all, there's those Lua scripts I mentioned. There's a few port detectors. You'll see that one of the ways you can write an application detector is say, hey, if it's on this port, if it's UDP, it's on this port, let's call it this application, right? There's not many of those because that's a pretty pathetic way to detect most applications. But there's a few, right? And if you know of one application, that's a very easy way to write a custom detector. But for the most part, detectors are going to want to be a lot more in-depth than that. We also have the app mapping.data, which is actually a text file database of all the different application detectors we have. And they have a number and a name that helps us keep track of them. Not a file you really need to mess with at all. But if you want to take a look and say, hey, can Snort detect this application? You can just look through this file. Right? That's where you start. So if you want to know, okay, hey, can it detect this? Well, normally I just grab this file, and that's going to tell me. Right? So there's a list of every detector we have without having to go through all the scripts or the code itself. Right? We got one handy list here. You can parse through and see, okay, is that application covered? Is that something I can detect already? And then the Lua libraries that we'll need to compile with. Right? So that's all in there. And if you take a look at it, it breaks out by a couple different directories. There's this ODP directory, which is the one we include. That has all our detectors and the mapping data there. And then it also create a custom directory with the Lua directory. So if you put any custom Lua scripts into that directory, it will automatically read them when Snort restarts. So if you write a custom detector, all you have to do is a pretty short Lua file, dump it in this directory, restart Snort, and we'll now be using your custom detector to detect whatever app we didn't know about or that you've customized. Right? You do not have to mess with the app mapping data. If you take a look at that file, it is a list of all the different detectors we have and maps them on everything. You don't have to mess with that. If you write a custom detector, just throw the script in the custom/Lua directory, and you're good to go. Right? So while there is a complicated database for what we use to manage all our stuff, if you are adding to it, you just got to throw the file directory. Right? So it's really pretty easy. Now, the way we do this is there are actually a few different ways we can identify an application. And you'll see that we sort of distinguish between service, client, payload, and miscellaneous. So in one given network session, there's actually an opportunity to identify 4 different applications. Right? So if we take a look at, say, okay, you go out to CNN.com, we're going to identify, first, okay, we know the protocol is HTTP, we know the client is Firefox, we know the web app is CNN. I'm coming from the other side, if we're looking at that as well, we're also going to say, okay, the web server is Apache version, whatever. Right? So we're going to be able to pull all that out. So there's a couple different layers at which we can look into this application data, and we're going to be able to call that up. You also want to make sure you're using the unified output. Right? Now, if you grab any of the recent documentation, it's going to tell you how to set this up. If you've been using Snort for a long time, you probably know that there are historically a lot of different ways to output the data. You could actually tell Snort, okay, output to syslog, output to my database, output to this flat file here. What we're really doing is getting away from all those different types of output in order to output to a single unified format, which is what we call the output we do. And what it is, it's a very simple binary format and allows the Snort engine to output the data as quickly as possible. Right? The idea being, the more time process is spending on writing anything to disk, the slower it's going to be. Right? Writing to disk is about the slowest thing a process can do. And if you're concerned about having to process a lot of traffic, about having enough hardware to analyze all your traffic, especially if you're inline and that server slowing down means adding latency to the network, speed is of the utmost importance. Right? So we want output to be as fast as possible. We're doing sort of a 2-stage attempt. We're just going to output to the unified format, which is just binary, and then use another program to parse out that data. Right? What you'll normally see is called Barnyard. Again, keeping with the pig theme, all the snort stuff has. Barnyard is used to usually pull out that data and then say, okay, do you want to put it then into your syslog? Do you want it then into your database or wherever you want that data? Right? So there's still multiple ways to get data into whatever format you want, but we're not going to have the snort process do that directly. We're going to have it focus on unified. Now, it's something we've been trying to push the snort community towards for a while. But I mention it here because if you're not using the unified output, if you are using one of the legacy ones, you're not going to be able to see that application ID information, right? You have to use that unified output to get the new fields that we've added. As we come up with new data types that you can get out of snort, the only way is to be using this unified format. So regardless, everyone should be using it, but if you want to do application identification and control, you absolutely have to or you're not going to see that data. So if we take a look at some of the output we get, again, it comes with a number of scripts we can utilize to analyze that unified format, right? Again, I've got one binary format, but it comes with, say, this one script called U2 Open App ID, which is going to read that format and outspit here we have like the application statistics we get. In this case, it was going to, just going out to CNN. Here is some, not all of the connections it identified, because it was getting too big. There's too much crap on the slide. I took some of it out. When you go to CNN.com, it makes many, many connections. It's a mess, right? And you can see we start to identify them here. That we can see, okay, the web browser is Chrome. We can see the DNS connection happened in the first place, right? What is CNN.com, giving the number back. I can see the protocol is HTTP. We see CNN.com are identified as a web app. But after that, a bunch of other connections happen. You can see there's DoubleClick, there's TrustE, there's Washington Times, there's Turner Broadcasting, there's Moat. Don't even know what it is. I'm sure it's some sort of advertising nonsense, right? So you see all that identified and what was actually just going out to one web page. Right? And you start to get these sort of statistics back. And you'll see for each line there, we're also tracking how many bytes are transmitted and received for that one application. So now we're going to be able to tell you what applications are on your network, and we'll tell you how much bandwidth they're using. So if you want to know, okay, why is the network a little slower now? We're going to be showing you not just what IPs are using the bandwidth, but what applications are. So you want to turn around immediately and say, hey, look, it's Netflix streaming that's suddenly using a lot more bandwidth. We're going to know exactly where that is and why. And of course, if we're inline, now you can write a rule to say, let's block Netflix streaming, right? So you can actually do that in application layer without having to block Netflix.com or just the IP address, right? You can block just the streaming because we identify that as a separate application. So you can let people go out to the Netflix.com and update their queue and do all that if anyone still gets disks. You still get disks? Anyway, if you wanted to, you can still go out to Netflix.com and do all that because we're actually blocking just that one sub-application, the streaming technology, right? We've also got the U2 SPUFU, because developers are just hilarious. What it's going to do is just dump all the data we have from that unified format. So when we take a look at, say, an IPS event, and here we have the output for a normal IPS event, but we'll see what we've added is a new field there, and I bolded it there. But we'll see for every IDS event we get, we'll also have the app ID for that session. So anytime we get an IDS alert, anytime we say, hey, there's an attack going on, there's something bad going on, there's a protocol anomaly, whatever it is we're identifying with the snort rules, for that session, we're going to be able to flag the application as well. Okay. So in this case, it's just a simple rule I threw together, and you can see, okay, well, we've got an error in this web request, and it's hitting off of red. So that data will be a part of all of our IPS data as well as our forensics information as we're collecting this packet information off of IDS alerts. And then also show this off, again, there are fields we add to the snort output in that unified format that some people are missing out on. So again, when you have a web alert data like this, you actually get a few other data types here, including the HTTP host name and URI. In this case, for every web attack, we'll also grab the URL. I mean, there's the host. So we'll have the entire URL of whatever site it was. We'll log that in additionally, which is not It's actually separate than the application identification. I just wanted to point out because there are a lot of people using very old database schemas to analyze snort data, and they're missing out on this type of data because we've added it fairly recently. All right, so one of the things we can do now that we have this application identification information is utilize that in the snort rules language. All right, so we actually add a new keyword to the snort rules language, right? So we have a series of keywords to identify traffic coming from this IP, going this IP, it's got these bytes in there, whatever it is we're looking for, right? A new keyword to identify traffic is the app ID keyword. So you can now put that into any snort rule. So right away, if you just want an alert anytime someone's using an application, very easy rule to write. If you just want to block a specific application, incredibly easy rule to write. But then again, if you're also writing, say, an IDS alert, looking for a specific vulnerability in a specific application, you can now just say, okay, app ID, whatever, right? So if you look at the process of writing a snort rule for, say, a DNS attack, the first part of your rule is narrowing down, hey, make sure this is DNS, right? Yeah, make sure it's port 53, but then also beyond that, check the first few bytes to make sure it's a DNS request, check the bytes after that, just to make sure that this is properly formatted packet, because we need to make sure we're only looking at DNS traffic, right? We want false positives on everything going port 53, we want to narrow it down. So if you were going to write a rule to look for an exploit for DNS, the first thing we do is add those layers. Okay, let's double check it's all DNS. You don't necessarily have to do that. It depends on the application and where it's all being identified, but if you're looking for a specific threat in a specific application, instead of having to write your rule and put in many sequences to say, hey, let's narrow this down to a specific application, if we already have a detector for it, you can just include that. That's going to save a lot of time writing rules for specific applications. All right, so let's take a look at how that would work. Maybe we want to block Reddit, so we'll get some more work done. So we want to put that rule out on the IPS, put it into block mode to make sure we're always blocking it, right? I want to block, I can't do it by IP, right? Reddit's so big now it's balanced over web services, so I can't just pick one IP and block it. And I certainly don't want to block all 80 in fact research. We can do just the one application, right? So all we need to do, the only thing we really need to make sure is, okay, what is that application identifier called in the snort database, right? If we've already got, first we want to check to see if we already have a detector for it, and if we do, what it's called. All I'm showing here is that we're going to search that app mapping.data file. And there's a lot of stuff in there. I say, look, if we just focus on the 7th column, we're going to have the name, and I'm just saying, okay, search for Reddit, and it comes back and it's just Reddit, all lowercase, Reddit. Right, so that'll do. All right, so now I know the keyword I need. So now I can write my snort rule. And here we have a very snort rule that's just say set up to block a couple of time-wasting sites. And again, very easy. Here we can see that every snort rule has the same header, if you haven't seen one before, right? Do we want to alert or block? What protocol are we dealing with? Source IP and port to destination IP and port. And I could narrow that down if I want, right? I could say, okay, only, maybe my machine or only my internal network is going to be blocked for snort if I want to keep that down, or if you want to maybe only block Reddit for a certain subnet at work, people you don't like, or just need to get back to work, right? Whatever it is, you can use all this information in the snort rules language to narrow it down. I don't have to block Reddit for everybody. I can get pretty specific, right? But in this case, I'm just doing it for everybody. From any IP to any IP, whatever it is. And you'll see I do a message file, which is just, what text does it show when that alert fires. And then you have my app ID keyword, and I put it through Facebook in as well, right? Facebook, Reddit, because I can have multiple app IDs in the same rule. And then I give it a number and revision number, right? Which is what we use to keep track of snort rules. Right? So at the core, what you're doing is copying the fundamentally basic template of any snort rule and adding, these words here, app ID, Reddit. That's pretty much all we really had to do in order to write a specific rule to block this application. So that's pretty easy. But one of the things we can also do is now it's very easy to customize what applications we're detecting. So let's take a look at what it would be to write a custom detector. And say maybe we want to take a look at tracking who's going to the BSides site. Right? We want to track that as a web application. So let's take a look at that. Now one option we have is just doing by port. Right? If I want to just identify an application by port and protocol, I can do that. It's lame, but I'll throw it out there because it's an option, right? In that case, you just throw together a simple YAML file and you say, okay, here's the name, here's the service name, here's the protocol, here's the port, and I'll give it an ID number. There we go. So if you've got a custom app that only runs on one specific port, you can do it this way. It's very easy to put together. Not very specific, probably prone to false positive that port is used by anything else, but it's an option, right? So let's look at something a little more in-depth and customizable. I said for most of our custom example detectors, we'll have a Lua script that looks like this, right? So what I'm showing you here is the entire script for a custom detector a colleague of mine wrote to track who is going to see the Washington, D.C. area craft beer festival. Right? So everyone going out to those sites you want to track, you can track them down, maybe you want to carpool, maybe you just want to know how many people get beer, whatever. He's tracking that application, right? So this is the entire thing. But now what I do is break down all these subsections and show you that while I have a slide here full of code, there's only like 2 or 3 lines you'd have to change if you wanted to write your own custom detector. That most of this is a skeleton framework that you'll see in every one of our detectors. So it's pretty easy to pick out what you need to customize, right? So let's look at the different parts this custom application detector had, right? First, I had an information header, which is nothing but a comment, right? A multi-line comment saying, hey, here's what I'm trying to do. It also has the included libraries, which is like, hey, I need those application detector libraries. Again, it doesn't change from any detector to another one. You copy and paste that right out of every other detector, right? So that's not something you need to think about or modify. Copy and paste that. Next one is the detector package. We're just going to say, okay, here's what I'm setting up, here's the protocol I want to use, here's the name I'm going to give it. And then we'll get into the functions where you customize your detection. There's 3 of those: initialization, validation, and the clean function. And I guess 95% of the time, the only thing you end up writing is the initialization one. It kind of depends on the application. Validation, actually I think I'll break these out here. Let's say information header, yeah, it's, again, just a comment. You know, the name, the version number, in case you're going to, change it, update it, improve it. We use that to keep track of it, and a short description. So nothing too big there. The included libraries, again, just these 2 lines. Right? I need to require this library here, which again we package. You can download. And then if you need other custom libraries, I mean, if you were to write something incredibly complicated and need your own library to do it, you could include that here. Right? I haven't needed to do that for any of the custom application detectors I've written, but it's an option. So it is extensible if you want to get crazy. The detector package info is really just, okay, here's the name I'm giving, here's the protocol I'm going to use, and then whether or not it's a client or server application that I'm going to be identifying. And then for each of those, we'll have init, validate, and clean functions, which we may or may not use. So the initialization function, so when that detector is loaded, it loads that up. And what it does is, so if there's certain static patterns, it loads those, all right? Because for static patterns, we can check those very quickly as it's processing packets and rule out what doesn't match those, right? So those load pretty quickly. We're also going to look at header patterns for like HTTP and SSL and the SIP protocol, because those are all applications that Snort is already piecing apart, right? There are other preprocessors built to normalize all that traffic. So by the time application data gets to application detection, if it's HTTP, we've already pulled apart that packet and said, here's where the header starts, here's where the body starts, here's the type of request, because we needed to know all that information to normalize that traffic, right? So all that data is available to us. The validation is where we do our deeper inspection. And here you're going to get like the same function as writing snort rules in C, which is actually an option as well. So if you want to check, okay, what's the size of the packet? If you want to take a look for specific strings and see if they're in there, and all that stuff, you can do that. And then the clean function is just whatever else you want to do after you're done detecting, right? And Lua handles memory management. That's not something you need to worry about. So the only thing I've ever used a clean function for is if I wanted to output some special data, which again, I've only done for like debug purposes. All right, by the time I finish an application detector, I don't ever use the clean function, so it's really something we can ignore. So what that leaves us with is something we can modify pretty quickly. So to piece apart, I had that whole, big slide that showed all the code. If we break that down into a couple pieces, you'll see we only need to modify a couple of things to write a custom BSides detector. So here's the header information. And I bolded the only fields I needed to change. I changed the name, and actually I didn't change the protocol, I just had to confirm that, yeah, TCP is right. Most ones I use are, so it's not something I usually change. Again, we're just copying and pasting that, but that is something you want to confirm. The rest of it I can leave. And then we get into the actual detection functions. So here's that entire detector function. But again, if you look at a few of these, you'll see that a lot of this, again, is just skeleton and how we set stuff up. So the only part I actually changed was this right here. I added this line, which uses the open add URL pattern function, which says if you've got a web application and you can identify it by URL, use this function here, put it in, and now I'll be scanning for it. So if I see a URL that says security.bsides.com, then I know it's this application I want to identify, right? So there are a number of these functions built in. So if you want to scan HTTP URL, if you want to scan the body data, if you want to scan, I mean the entire packet itself if you want, but I've already pulled apart the HTTP information. If I just want to look at the URL, that's already there for me. All right, so there's a lot of that information to pull out. If it turned out that like security BSides is all HTTPS, and I still want to track it, we've actually got functions in there to identify by certificate name, right? So if you take a look at your custom web application, it's got its own cert, then yeah, it's all encrypted, but I can still identify the application because we can pull out those cert names, right? If that's unique. If you use one cert for everything in your company, then it might not really help you much. If you've got a specific cert for a custom application server, we can still write an application detector to pick that up, even though it's encrypted, right? Which is actually how we do detection for, say, Gmail, right? We don't pick Gmail up as all Google. Every one of Google's services actually has its own cert. So even though it's all encrypted, we can identify and even block Gmail. Again, because we can identify it by certificate before it's really all encrypted. That's all I had to change, and then I actually added a second line. Again, it's the same real function we had before. I just added a second one to say there's actually another URL we might consider BSides because we had a different site there for the schedule. So I'll put a different one in for the BSides schedule and say, okay, if it's this URL, right, on busyconf.com, then I'll pick that up as well. At one point, application names have to be 16 characters or less. That one took me a while to figure out. It was not super verbose in the error I had for that one. But it will not load if your application name is longer than 16 characters. So watch out for that. All right, so I've got my script. I've got essentially bsides.lua. Right, it's this little script I've got. So I throw that in the application directory. I've already identified it in my snort.conf. I put that in the custom/lua directory, and I restart snort. And now I'm scanning all of the web traffic going through that box for traffic that could be identified as BSides. I'll actually show you what's there. If you look into your snort logs, you'll see that you get like a traditional snort.log, which is your IDS events that are firing. And then you get, here I've got my app stats unified file as well. So that is the actual application statistics we're seeing, what applications are identified, how much traffic are we seeing. So if I want to pick that out, again, I've got a script that comes with snort. It's in the tools directory when you download the source, this YouTube open app ID. And if I fire that off on our log, and I remember my password. I don't know if you can see that, but here we have a session where I recorded going out to the BSides site and what it picked up. In this case, you can see first thing we identify is Firefox and HTTP, right? So we got the protocol and browser client I used, and then it picks up BSides, right? So our application, our custom app fired off of this this application stream. We also see Google in there. I should come to think about the first thing I went to Google, searched for Columbus BSides, and then clicked the link. Right? So it actually picks us up sort of one stream, at least by a timestamp. It sort of does one session. You see the timestamp sort of changes right here. So it picks everything up. That entire process is sort of one session, right? So we actually pick up, there's DNS, right? So I asked for google.com, right? The first thing it sees is DNS, it identifies Google. I go to BSides and see all that. So you can see there, again, we pick up Firefox, not only going to Google, but then going into another site. We pick up Google Analytics, what's been on that site as well. We pick up the protocol again. We got HTTP and HTTPS we saw in there. There's actually SSL client firing as well. Yes, I don't think it was just my web session, because I don't think that was SSL, and we also see application of Ubuntu. So I think my system may have been checking for updates at the same time. I'm apparently using Detector and flag down that. And again, we see part of that same session picked up BSides twice. I don't know if it reloaded or if there's another page embedded in it. And then from there, I went to the schedule, so I actually see by the timestamp, here's another session. Again, DNS to look up the site. I know it's Firefox over HTTP. Apparently, there's some LinkedIn in that site on HTTPS, but again, we pick up the BSides schedule, which I loaded as a different application identifier based on its own, right? There's literally a couple of minutes to do this, because I could look at a different web app and say, okay, we'll copy all this, paste it, and I'm going to change this. Which is most of the custom web apps we run into, right? Most custom web apps we run into, we narrow down by host and by URL. Especially for ones in your business, you might want to pick up and identify who's using this application if you want to track that information. If it's not a web application, there's still a lot we can do here. Again, you have the full power of the Snort engine to dig into a packet, to search it for a specific series of bytes, check those here and this here. So there's a lot you can do. So even if it's a custom protocol, there's certainly ways to dig into it. But for most web applications, if that's what you want to identify, incredibly simple to write a custom detector and get that working. Again, there's a number of functions you can use there. So if you want to match off of the cert pattern or the certificate name, you can do that. So you can catch some apps even if they're SSL. We've got memory compare functions, and again, sort of everything that's built that you can use in a snort rule, you can utilize in those Lewis scripts to pick apart that traffic, to search for things, to match patterns, whatever it is you want to do to look through that. That data lends itself pretty easily to visualization of Splunk. The way that data outputs, and I showed that here, right? So the way this data comes out, you can dump this immediately into Splunk. It's incredibly easy to parse through it. I'll show you, I've got some loaded here. All right, so we look at it, and again, because of the way the data was formatted, it was able to pick out the fields immediately. So here you're going to see application name, host, transmitted bytes, received bytes. They're all there. So even at a glance, without having to do any customization, I can click here. Okay, and here's my top applications, right? Although it's doing this by like number of sessions. We can see DNS is most popular, right? So what it's doing is by number of sessions, DNS is the most common up there. But if I want to, say, format the search and do it by, okay, let me update that. So here I have it evaluating, I've actually created a new field called total bytes, right, where I just add together TX bytes and RX bytes. So now I have the total field, and we're saying, okay, chart that out, and then sort it by total. So here I have the same data, but we're sorting all the applications that are on my network by how much traffic they're utilizing. In that case, we see HTTP was up top, followed by Apple updates, and the Mac Store again probably show the same updates, and then Hulu Plus, apparently one of the more bandwidth-heavy applications on my own network. So again, I can go through now and pick apart that and see, okay, what applications are out there, and then which ones are using the most bandwidth. And I've never used Splunk before, right? This was just like a fun way to learn it, because of course, I mean, why not learn something new for a talk, right? But it was just a matter of really getting the evaluation copy fired up and dumping this data into it. And I mean, within half an hour, I was putting together different dashboards and things to track this information, right? So very easy to start to play with this data and start to see what applications are out there. And if you've used Splunk before, you'll probably come up with way prettier stuff than what I'm doing here. But it's very easy to see what applications are out there, how much data they're using, as well as tie that back to where it's coming from the network. Right? All right, so we've got that. I showed the top apps. And then sort of pivot from there, I was going to sort of move from application detection and talk about file inspection. So yeah, it's something we want to get into with It's something we can do with snort. It's not something I see a lot of people doing, but I think there's incredible power here to be able to analyze files, to capture files off the network, or do checking by file type. Those are all things we can do with snort. It's not on by default, not a lot of people are using it, but those are capabilities we can turn on as well. So we can also include, with those file APIs, we do file type identification. So if we want to pick out files that are traversing the network and identify their file type, we can do that. And again, it does that by file magic, not by just like file name extension. Right? It doesn't really care what that is. It looks into the file to determine what file type it is. We can do file signature collection. So we can actually grab the hash of files going across the network. So we can keep track of them that way. We can also block files that way. So if you're getting threat intel from VirusTotal or wherever, it's saying, look, we've seen this malware, here's the hash of that malware. You can load that into a flat file, feed it to snort, we can turn around and start blocking those bad files. So without having to see the attack happening in the traditional view of an IDS, right, which is, okay, if I see an attack happening, if I see a vulnerability being exploited, we'll alert on that, we'll block that. We can say if we see a file being transferred that is no malware, you got the hash, we'll load this file, now we'll block that from being transmitted across your network altogether. It also allows you to do file capture, which of course is the start of any more in-depth analysis. So if you want to capture files that are going across your network, now we can say, okay, well, what else can we do with that file? What other analysis can we do with a file, right? Now let's run it through antivirus. Let's run it through a bunch of Yara signatures, right? Let's send it to a sandbox. But now that we have a file and it's saved off, we can start to do more with it. More than an IDS can, which I think is important, right? Because IDS has been absolutely pigeonholed since Gartner declared IDS was dead. Right, that's about 10 years ago. Those of us who made a career in IDS are still no better. But Gartner came out and said IDS is dead, and the reason why is that nobody cares about a security system that says, hey, there's an issue, you might want to look at it. It's not blocking, it's not helpful. And then the rush began to, okay, it has to be an IPS. We have to be able to block. And that means I can block stuff that I can inspect and then verify without ever slowing down your network, right? Because an IPS is slowing down your network and introducing latency, no one would use it. That's not an option. So complicated detection is off the table for IDS. If you really want to see if there's an exploit in a PDF, you have to pull the document out, analyze all the different objects embedded in a PDF, and how they might be written, and all the different stuff that can be in there. You know how much crap you can load in a PDF? JavaScript, Flash files, you can put all sorts of stuff, right? You can't do that at line speed. So your IDS can't do that, right? So if we want to do more complicated malware detection, first step is capturing a file so that we can do something else to look at it. All right, so we want to get into a triage mode and say, okay, you capture the file, now I'm going to take a look at it and say, okay, well, take a look at it. If it's a known bad file, yeah, of course, it's easy. We'll block it on the wire. We can do that with the hash. But what else do we want to look at, right? And then we can also do file control. So if you just want to block certain file types from going across your network, you can. So if you've got an IPS positioned at the border of the network, you just want to block anything you can see as an executable, you can do that. All right, we'll take the rules we have for identifying files, change alert to block, and now we can say, hey, if we see this, then let's stop it. All right, so if you want to write the rule and say, okay, well, all this CIDR block here is HR, for them at least, let's make sure they're not downloading any executable files from the internet. Right? So let's get those types of rules in there. And again, that'll turn on file capture as well. For file capture and for blocking files, based on hash, we can do that for HTTP, SMTP, IMAP, POP3, FTP, and SMB. So we can see into those protocols. Snort is already aware of those protocols, how they work. If we see files being transferred that way, we'll be able to grab those files. So for web downloads, email attachments, FTP transfers, and net files transfers, we'll be able to pull those files out. We'll be able to identify what file type they are, give you the option to capture those files, and potentially block them based on known bad files you have, right? And the signature we use by default is SHA-256. There's options in the Snort language to change that if you like, and you can utilize the OpenSSL libraries if you prefer those, but we're using SHA-256 by default. I know MD5 is popular, but we're seeing way too many collisions to bother with it, right? So what are the requirements? I mean, you have to have those other preprocessors, and they're all on by default. But you have to be, you have to rebuild TCP or IP fragments, you have to assemble a TCP stream, because if you don't do that, then we can't see the application layer to know how FTP or an email attachment works, right? So you have to be able to reassemble this data. But again, all those things are on by default. And you have to compile it with enable file inspect, right? So if you haven't been doing file inspect before, your snort might not be set up for it. You may have to recompile to get those features turned on. But otherwise, they're built in there. Then I can go into my snort.conf and I can add my config here and say, hey, I want to track files. And you're going to get some options here that you can sort of tweak for performance. Because you're going to be able to, again, the defaults will work for most of you, but I just want to point out there's a lot of performance tweaking you can do by changing these numbers here. Because like your file type depth is how far into a file do I look to figure out just its file type, right? Do I search for file magic? And typically we don't have to look into the whole file to pick that out, right? Usually the first chunk of a file is going to have what file type it is. We don't have to scan the whole thing. We'll save some performance there. We do file signature depth again for capturing the SHA-256, comparing it to your blacklist and saying we should block a file. We can see how far in do we want to look at that. We also do file block timeout. So if a file is transmitted via HTTP and we block it, right? Someone might just say, okay, try again. And then we need to track that session so they can't just resume their download, right? So by default, it's doing that for a day. And you can change that. And then you can set like the memory cap, which is just like internally how much memory will snort use for doing the file preprocessing. So again, a performance tweak if you find yourself running low on RAM or it's getting slow. And then you've got your file capture max and min size, which is saying if the file is bigger than this, I don't want to capture it. If the file is smaller than this, I don't want to capture it. I've got 0 here, but for the most part, if you're looking for malware, you can have something greater than 0 to say, look, if the file is small, there's nothing useful going on there, right? And you need to add your snort.conf this include filemagic.conf, which is literally a list of all the different file types and the way we identify them. So you've already got all the rules to identify different file types, right? That comes with snort. You don't have to write those or anything. So we already know what all the major file types look like. We'll be able to identify those out of the box. Tarball, as it is. And then we can add our preprocessor config. So I can just say, hey, I want to identify file types. I want to do the signature configuration, or not. You can leave that off if you don't want to calculate the SHA-256 each file. And I can specify where I'm going to capture it. So there's the directory of the disk I'm going to capture files, and how much memory to use that. So snort will actually keep 300 megs in this case aside for file storage. If it goes over that, it'll delete the oldest files to match that. So it's sort of built in to make sure you're not going to fill up your disk doing file capture. All right? So you can change how much space is set aside for that. You can also configure this to just dump files to a remote server. It's built in just to send files to a remote server if you'd rather do it that way instead of having it on your snort sensor. And like the snort download comes with even like a server script. You can see like, how do I take those files? So if you want that off box, you can do that too. And then I'll give it, my blacklist and gray list. So each of these text files is just a list of SHA-256s. So if you've got known bad files, put them in this block list here. We see those files, we'll block them. And if they're in the gray list, we won't block them, but you'll get an alert. Right? Hey, I saw this file. All right, so that's literally just a text file. On each line is a SHA-256 is something we want to block. So if you get a file, you get some intel, you find malware in your system, all you need to do is calculate the SHA-256 for that file. Like this evil file.jar. Redundant, right? Java file. Block them all. And then we'll just output that into our block list, right? So again, if you see malware, calculate the SHA-256, dump it in here, but you could also be going out to VirusTotal and look what other threats are out there. Copy the SHA-256 and paste it in here, right? So there's a lot of threat intelligence services that are able to provide information on what files you might be blocking as well. Give you a quick look at that file type identification. Well, we've got that file magic conf that has all these file types. So you'll see a lot of these rules like this. Okay, we're looking at a zip file and a version, and here's the strings we're looking for to identify it. So all these rules are already built in, and then you can build alert files and say, hey, if you see those, I want an alert. And of course, if I wanted to block this type, I don't know why you would for an image, but say you just really wanted to block all GIF files, I change alert here to block on my rule, restart snort, and I will block those types of files. Otherwise, you can also export this data all these rules fire off with a different generator ID than the IPS alerts. So you can actually search your alerts by GID. Everything for 146 is going to be, hey, I saw this file type. So you can immediately take those alerts and put them somewhere else. You can separate them from your IPS alerts and say, hey, there's a security issue you want to take a look at. And now we've got stats on file types that are going across your network. And you can very easily dump those in Splunk and say, okay, what percentage of files on my network are Word documents or PDFs or executables? And you'll have that information at your fingertips. And we can do file capture, again, right? In order to do a file capture, it has to be a known file type, right? So we have to have one of those rules. In order to do file capture, we have to be able to identify it by type. And if we can, you can capture the file. And like I said, we've got a server there if you want it off box. So now you can capture files. And when it happens, you'll get an alert like this one. So I say, okay, here's the date and time. Here's the original URL, right? WP content, themes, images, logo.jpg. So there's the original URL of that file. Here's the file size. Here's the SHA-256. If you want to look it up and keep track of it, or turn around and start blocking it. And then there's like the IPs we saw it from and then to. So you'll have all that information about file transfers. Each file transfer, at least for the protocols we inspect, right, the list we went through, you'll have all that information about what's going on in your network. So you captured a file, right? Why would you do that? I mean, you can look into them, but the idea is maybe there's some more security we can do now that we've got a file off of there. I usually start with Clam-not-just-AV, right? This Clam-not-just-AV can actually do a lot for us. And again, even aside from antivirus, it's actually very good at pulling apart a file, analyzing it, figuring out what file type it is, and how we should inspect it. So Clam-not-just-AV is where I start, because again, it's not just AV. Yeah, it's got AV, so one thing I can do is run against all the signatures we already have and see if it's a known threat, right? I can't do that at wire speed. It takes a while to run AV. It's a slow process. I also know AV is pretty crowded, right? If it worked, you know, we wouldn't be here trying to learn more things about security, right? But there's a lot that an engine can do, right? In order to do antivirus well, it has to, again, like an IDS has to normalize traffic, a good antivirus engine has to normalize the files it's looking at. And because it's doing that, we can actually learn a lot from that. So if you're pulling apart files, you can actually use Clam to say unpack a file. Right, if it's unpacked with something standard like UPX or Petite or one of the well-known ones like that, Clam will automatically unpack it. So not only will we be analyzing it that way, but you can get it to save the unpacked version if you want to do more analysis, right? It'll also normalize files. It'll also allow you to do custom signatures. Right, so a very well-known standard for doing custom signatures, and we can do all those things. All right. So if we want to unpack files, again, if you run ClamScan and use debug, will tell you everything we learn about that file. And if you give this leave temps option, it will leave all the temporary files it builds. So if you look at, let's see. Or here, let's do this. I've got a packed file here. I think I'll identify that. Scan.exe. So I found this executable. It's a network scanner an attacker used. And it comes through and identifies. So if I want to turn on my behavioral profile to detect potentially unwanted applications, not just viruses, and it'll come back and tell me like, hey, this is a little weird. It's UPX packed. All right, so maybe that's something suspicious I want to take a look at. You know, I can run this again, show me the debug information, and leave the temporary files. It'll run through, it'll tell you everything it's doing, but it'll also tell you a lot of information about that executable. So if I take a look at, let's see, the first time it sees this file, we can see, okay, here are the PD sections. Right, here's section 0. It's called UPX 0, and it looks to be encrypted.
You have about 2 minutes, 3 minutes.
Okay. All right, no problem. But if we scan down here, you'll actually see it says, hey, we identified a UPX, and we've decompressed the data. And we've saved it here. So I've actually told it to save the decompressed data. So now we have the unpacked executable as well. Right? So I run, say, strings on that scanner file. I get what, a list of a very short list of DLLs and nonsense. Right? If I run strings on the decompressed file that Clam saved for me, I get all this information. And I can see pretty quick here, oh, check for updates for superscan by visiting Foundstone. And now how it is. Some attacker had loaded the network scanner on the system they compromised as well. And it's just Foundstone superscan. But it was packed and I couldn't quite see that right at first, right? But now that I've got a file captured off, I can do things and analyze this in ways that Snort never could. And I can utilize Clam for that. So I depacked it, I can detect this potentially unwanted applications. We can do a lot of fuzzy matching for images. So actually there was a file I grabbed. Here we go. So there's an executable file I grabbed. Wasn't sure if it was malware or not, but we looked at, again, Clam analyzed and it pulls out the image files because it looks for executables in there. And it's using the Internet Explorer icon. Right? So I'm a little suspicious there. You get a lot of information you can do. Now we've got a file saved off, we can do additional analysis. Right? Now I'm getting the hook. If you have any questions, I'm happy to stick around and answer any questions, or show you where to download the stuff or get up and running. Any other questions, just hang around and ask them. Happy to talk about this stuff until they kick us out of here. So thank you guys for coming to the talk.